Let's look at some other cool properties about pressure. If I had a bubble and I looked at the inside and looked at the pressure on the inside of it, unlike a force which acts in one direction, pressure acts in all directions and always acts perpendicular to the surface. So my little pressure arrows are perpendicular to the surface here. If I look at a bubble that's not changing size, it's not getting bigger, not getting smaller, that means the pressure on the outside is equal to the pressure on the inside. So if I have 1 atmosphere on the outside, I also have 1 atmosphere of pressure on the inside. And that's kind of to our Dr. Seuss rules of physics, but I know really the bubble has some elasticity to it, but I'm going to go ahead and just ignore that for the sake of the entry-level conversation we're having. Now, unlike force, remember it doesn't act in one direction, so the diver is not being pushed up or pushed down or left and right by pressure, because the pressure acts in the same direction, acts in all directions on the diver. If I bring up some type of underground cave, for example, that has the same depth as the diver, call it position A, then when I look at it, this pressure is going to be the same. Even though it reaches lower than the diver, by the time the water gets up, the pressure is going to be the same at level A inside my cave as it is on the diver itself, because it acts in all directions. Okay, so why wouldn't you choose high heels to walk in the snow? Well, let's see. Pressure is force over area. The force, if you're wearing boots, is due to your weight going down the heel. The heel is really small, so big weight, little heel, big pressure. And that pressure will push the boot down through the snow. So the next question is, what do you have to change about the boot so it doesn't sink? So pressure over area. Pressure over area. Can't change the weight, but if I make the area bigger, that'll make the pressure smaller in our fraction. So basically, I'll put a snowshoe in the bottom of the boot. Well, okay, that's not very fashionable. And this is what a snowshoe really looks like. But you get the idea. So the Earth's atmosphere has mass. If it has mass, gravity pulls on it and that gives it weight. And that exerts pressure on you. So here's the ground of the Earth, and then here's all the mass around us due to the air, and that's being pulled downwards, and that gives it weight on top of us. So we call that 1 atmosphere of pressure, or 1 ATM. Now, 1 atmosphere of pressure is also defined as 1.013 times 10 to the 5th newtons per meter squared. Except we don't call it newtons per meter squared. We named a newton per meter squared after another person, so we call it pascals with a capital P. On the AP exam, you wouldn't use the 1.013. Instead, you would just use 100,000 pascals, and that's equal to 1 atmosphere. It just makes the calculations quick, and it is a time crunch on the AP exam. So let's look a little bit more at this, another unit of pressure. Imagine on top of your head, there's a little square that's 1 inch by 1 inch, and there's a column of air going all the way up until we're out of the Earth's atmosphere. So here it is, all the way up, 1 inch by 1 inch. That column of air would weigh 14.7 pounds under ideal conditions. So therefore the pressure is 14.7 pounds per square inch. Alright, now let's look at a barometer. Here's a little YouTube video.
I'm going to make a barometer. And what I have here is a glass tube that's about 800 millimeters long. And I've filled it with mercury almost to the top. And I'm going to finish filling it so that I get filled all the way to the very top. And then I'm going to put my finger over the end and I'm going to invert it into the mercury. I'm going to set it here and use our clamp to hold it. Now, what's keeping this mercury column so high? It's that atmospheric pressure pushing down on the mercury, pushing this up. And let's see how tall our column is. 744 millimeters. It doesn't matter what size the diameter of our tube is, as long as it's relatively small. You can see this one's really small. I have another one that's almost twice the diameter of this one. But you can see that the level is the same in both tubes. What we're going to do is compare this crooked barometer to the barometer that we already have. And notice it rises to the same level.
Now, you really don't want to do this because the mercury is very dangerous to work with and the vapors aren't something you want to be around. But you get the basic idea. But that's a mercury barometer. And the reason why I'm bringing that up is because one of the ways that pressure is measured is with a mercury barometer. So 1 atmosphere of pressure happens to be equal to 760 millimeters of mercury. So the atmosphere pushes down on the container on the outside, and that pushing down pushes the mercury up in the tube, and on ideal conditions, it pushes it up 760 millimeters, which is equal to 29.92 inches in height. So sometimes you'll hear that reference of the number of inches of mercury or the millimeters of mercury, and what it's doing is it's talking about this barometer and comparing it to 1 atmosphere of pressure. And this is what a barometer looks like if you had one in the science classroom. It's a pretty simple device, but again, we don't have them now because the mercury vapors, you don't want those to go out in the class. Here's a device that works similar to a barometer. This is actually an automatic watering bowl for a dog. And so the barometer is on the right-hand side. It's the bottle. There's a partial vacuum at the top, and then the atmospheric pressure is helping to keep the water up in the bottle. So basically, it's a little barometer with water. And but it cheats a little bit, but you get the basic idea. Pressure on the water in the bowl helps to keep the water up into the bottle, and there's a little bit of a vacuum at the top. Another place you've seen barometer, in the weather. So if you look at it here, you can see the barometer is 30 inches of mercury. That's a little bit higher than a 29.92 inches, but that's how the pressure's reported to you.